Thinking it would be fun, you climb up on top of the school to drop water balloons on the teachers as they arrive to work in the morning. How long do the teachers have to get out of the way if you're on the roof 10 meters above them? So as usual, we have our picture drawn. Here's you dropping your water balloon onto a poor teacher's head. Come on, man, they don't deserve that. 10 meters below, initial velocity is 0 because the problem says you are dropping it, not throwing it. And as always, acceleration down negative 9.8 meters per second squared. So now we're going to pull some numbers out. The displacement of the water balloon is down, so negative 10 meters. Initial velocity is 0 meters per second because we're dropping it and not throwing it. The acceleration is negative 9.8 meters per second squared. And the question asked, how long do they have to get out of the way? That's time. From here, I'm going to pick the equation that does not have the f in it. That's going to be our third equation. D equals v naught t plus 1/2 a t squared. My life is going to be made a little bit easier by the fact that v naught is 0. And because v naught is 0, 0 times t is just going to cancel. It's going to make my life a whole lot easier. Because I can rewrite the equation now, d equals 1/2 a t squared. Solving for time, first thing I'm going to do is I'm going to get rid of the half and the a. I don't like having fractions in my denominator, so I don't like to divide by a half, because dividing by half is the same thing as multiplying by 2. So we multiply by 2 to turn that into 2d. That gets rid of the 1/2, and I'll divide the a, and that's going to leave t squared over on the right side. We don't want t squared, we just want t. So to get rid of the squared, I do the square root. Now we can plug in our numbers and solve. That would leave us with 2 times negative 10 meters all over negative 9.8 meters per second squared, and all of that underneath the square root sign. Once I plug all that into my calculator, I get 1.43 seconds. That's not for D, for time. So 1.43 seconds is how long the teachers are going to have to get out of the way.